All right, good morning, good afternoon, or good evening, depending on what time you are actually watching this video. Today's lesson 6.2 today, we are going to talk about solving systems of equations algebraically. We're going to talk and take a look at some different ways we can solve it without actually having to graph it. Now you might be saying, why do I want Mr. Parts to know how to do a system by other than graphing? I mean, I got graphing down really well. So the reason why is sometimes the answers don't always intersect nicely or they're difficult to graph. So let's take a look at this one here and just kind of look at how graphing can be a little bit more difficult. So on this one it says 2x plus 3y equals 2. So the first step is, again, we got to get y by itself. So I got to subtract 2x from both sides. So I have 3y equals 2 minus 2x. Then divide everything by 3. So now I have y equals, look at this, 2/3 minus 2/3 x. Now all of a sudden I'm starting to get fractions. So my y-intercept is at negative 2/3. My slope is also at negative 2/3. That means as I rise, I have to go down 2 as I run to the right 3. So I start at 2/3, so I gotta kind of estimate that value. So now I need to go down 1, 2, to the right 3. So I'm estimating that again somewhere kind of in the middle. Down 1, 2, to the right 3. Down 2, 1, 2, somewhere to the right 3. I could go up 2 to the left 3 also. So I'm going to do that a couple times too, just so that I get some decent and nice points to do. All right, so now let's take a look at the second one. Same process. This one's a little bit easier in that I can subtract 4x. So I have y equals negative 6 minus 4x. So my y-intercept, I always want to write slope first, is negative 6. My slope is negative 4/1. So I'm rise, meaning I'm going down 4 while I run 1. So start at negative 6, 2, 4, 6. Okay, whoops. Put a dot right there. Almost put the dot in the wrong spot. So now I need to rise, so down 4 to the right 1. So I'm better off going up 4 to the left 1. Up 4 to the left 1. So at least I'm getting a point of intersection there. And it looks like it's at negative 2, 2. But, you know, with this whole 2/3 bit part, I'm not even 100% sure. That's why checking is going to help us out here. So that graphing of 2/3, I'm not 100% sure, but let's check to see if this point's right. So in the first equation, so I'm checking it in this equation first, 2 times negative 2 plus 3 times positive 2, does that equal 2? Well, that's negative 4, that's positive 6. Negative 4 and 6 does equal 2. Well, that's looking good. So let's check it in the second equation. So 4 times negative 2 plus the y value 2, does that equal, not 2, Mr. Bartz, does that equal negative 6? So multiply negative 8 plus 2. Negative 8 plus 2 does equal negative 6. Whoops. Hate it when I hit the side too close because it kicks it down to the bottom. And that checks off. So yeah, graphing worked. It got a little hairy here with these 2/3. And I know how much sometimes we don't like to work with fractions. So, as it says here, we can solve it by graphing, but it can get difficult and hard to determine where the points are located. So, is there another way? There's several ways we're going to teach you over the next few days. The first of these ways is called the substitution method. Okay? So, how does the substitution method works? So here are your steps that you will want to follow. When I think of substitution, I think of when Mr. Bartz is gone as a teacher. someone comes and replaces me. We call that person the substitute. In essence, that's what you're going to be doing with these equations. You're going to replace the variable in one equation with what it equals in another equation. So I'm going to take you through these 5 steps here when solving a system for this exact problem that we just did up top. So step 1 says, solve one equation for one of the variables. Okay? So you don't have to do it for both, you just have to do it for one. So when you have to decide, when I look at them, I look at, do I have just an x or a y? And can I get it by itself pretty easily? And I can do that pretty easily with that second equation. Remember when we graphed it, we just moved the x's over to the other side. So I had y equals -6 minus 4x. So I've done the first step. Now here comes the second step. So I'm going to kind of color code this. Substitute each equation in step 1 into the other equation to replace the variable. So what I'm going to do is I'm going to go to this second equation. I'm going to take what y equals here, this piece right here, and I'm going to put it in this spot right here. In essence, I'm going to substitute it. So now I'm going to write this whole equation, but with what y equaled in the second equation, I'm putting it in the first. So I have 2x plus 3. Now I put all this stuff in for y. -6 minus 4x equals 2. Okay, done step 2. Step 3 now. Okay, let's see, let's go this color. Solve the equation for the variable. So I'm solving this particular equation for x. So I got some algebra to do. I have 2x, so I have to remember our distributive property. 3 times -6 minus 18. 3 times -4, -12x equals 2. I'm going to keep on doing my algebra here. So I'm going to combine like terms. So 2x and -12x makes -10x. I still have this minus 18 equals 2. Trying to get x by itself, so I move the number now to the other side by adding 18 to both sides. Crosses out, -10x equals 20. Divide by -10, x equals -2. Now, I've solved for the variable. I've done that step. The next step, which many students forget, substitute the solution from step 3 into either equation to solve for the other variable. So what I like to do is I like to take this in and actually substitute it into my equation where I have y already by itself. Makes it pretty easy to solve for y. Meaning, I'm going to go y equals -6 minus 4 times -2. So y equals -6. A negative times a negative makes a positive. Y equals +2. Notice how we got the exact same answer, -2, 2, as we did when we graphed it up here. Notice how it's the exact same answer right here. Okay? So the last step is you want to state your solution. You can just leave it as this, or if you like to write it as an ordered pair, you can do that. And really, there really should be a step 6, and that is to check it. So make sure it does work in both equations. I'm not going to demonstrate that here because we already know it works because we knew it worked from graphing. All right, let's go to the next page. Okay? So now, when solving systems of equations algebraically using this substitution method, sometimes we get answers that are no solutions, and sometimes we get infinitely many solution answers. The question becomes, how does that work out algebraically? So I'm purposely going to show you an example of each here so you can see when that happens and what shows up when you solve it algebraically. All right, so to go through the steps here, step 1 again is to get one of the variables by itself. So like on this first equation, notice how y is already all by itself. So I can go right to step 2, where I take what y equals, and I'm going to put it in the place of y in the first equation. So I can write 8x, so I'm writing the first equation here, plus 4, replace the y with what it equals, negative 2x plus 3, and it equals, back up here, 12. So now, step 3 was to distribute and solve. So I have 8x plus 4 times negative 2x is negative 8x. 4 times 3 is 12 equals 12. So now when you start to combine like terms, notice how the x's here cancel each other out. 8x plus negative 8x is 0. 0 plus 12 is 12. 12 equals 12. This is a true statement. When this happens, okay, 12 equals 12, it's like saying both equations are the same. Okay, so they are the same equation. When they're the same equation, even though they totally look different, they actually were exactly the same. And when you graph same equations, you get infinitely many solutions. So what will happen for infinitely many solutions is you're going to have a number equal the exact same number, or they're going to equal each other here when you simplify. When that happens, you get infinitely many solutions. All right, let's take a look at the second one. So the second one, notice how in the second equation, at least x was all by itself. So what's nice here is I can go right to step 2 and plug in what x equals into the first equation. So I have 5, replace the x with this, 2y plus 10, and then I'll have minus 10y equals 22. So now step 3 says to solve it algebraically. Okay, so or solve for y. So 10y plus 5 times 10 is 50 minus 10y equals 22. So when I combine my y's, 10y and negative 10y, they cancel out. I'm just left with 50. 50 equals 22. Wait a minute. 50 can't equal 22. This is a false statement. Because it's a false statement, that means it's not possible. You get no solution. Okay? So what that means is you have parallel lines. Okay? So what happens is when you solve algebraically and the variables cancel and you have a false statement where you have a number saying equaling a different number, and we know that's not true, that's the no solution. Parallel lines. If they are actually equal back over here, that's where you get infinitely many solutions. All right, so I demonstrated an example of each possible solution. Now, how can we put this into actually real life situations? So let's take a look at a word problem using the substitution method. So here we go. It says Lancaster Woodworkers Furniture Store builds 2 types of wooden outdoor chairs. A rocking chair that sells for $265 and an Adirondack chair with footstools sells for $320. The books show that last month business earned $13,930 for 48 outdoor chairs sold. How many rocking chairs were sold? Wow. How do we go about answering a question like this? So notice how I kind of have things laid out here for us. So the first thing it says, define your variables. So your variables have to come into, here it says how many rocking chairs were sold, but we also were making Adirondack chairs with footstools. So we need to define those variables. So in these problems, you'll always have 2. And I always like to use x and y, but technically you can use whatever letters you want. So for x, I'm going to let it be the one that I want, rocking chair, specifically the number rocking chairs sold. Y is going to be the number of Adirondack chairs sold. So if you're wondering what an Adirondack chair looks like, go online, type it in, and take a look at it. It's those nice big wood chairs that you sometimes see up at cabins up north. Maybe some of you even have one at home. All right, so now, question number 2 says write a system of equations. So from this information, I have to write 2 equations. And the reason why I say 2 is because I have 2 variables. Since I have 2 variables, 2 equations. So, 1 dealt with how many chairs we sold. We sold 48 chairs. So what I know is the number of rocking chairs sold, which is X, plus the number of Adirondack chairs sold, which is Y. Those 2 numbers together have to add up to 48. My second equation comes with the money. So a rocking chair sells for $265. So I go $265 times the number of rocking chairs I sold, which is X. I don't know what that is. If I sold 10, I would have made $2,650 because I go 265 times 10. Since I don't know what it is, I put an X there. Plus the amount I'm making for the Adirondack chairs, which is $320. So 320 times the number of Adirondack chairs sold, Y, that equals all the money the company made, the $13,930. So now I have my 2 equations. So now it says let's use the substitution method to solve. So I'm going to take this equation right here and decide to get one of the variables all by itself. Okay? It doesn't matter. So I might get X by itself by subtracting Y. So if I subtract Y from both sides, I get X equals 48 minus Y. Okay? So again, it didn't matter which one you did, but I did that one. So now, remember, our next step will be to take this answer and plug it into the second equation. So as I do that, I will say 265 equals 48 minus Y plus 320 Y equals this 13,930. So now let's start solving for Y. So I'm going to distribute. So 265 times 48. So is 12,720 minus 265y plus 320y equals 13,930. So now I'm going to combine like terms. We'll combine these 2 together. So 320 minus 265 leaves me 55y. I'm going to kind of do a same step. I'm going to take the number and subtract it to the other side. So now if I subtract those 2, I'm actually going to do this old-fashioned. 3 minus 2 is 1, 9 minus 7 is 2. Okay, 1. So I get 1,210. Now I can divide by 55, and y equals, so 1210 divided by 55 should be y equals 22. Okay. So if y equals 22, what I can do is plug that back in here. X will equal 48 minus 22, which is 26. So the question was, how many rocking chairs were sold? Well, that's the X value. So 26 rocking chairs. shares were sold. Now, even though they didn't ask you, I'm just going to note that 22 Adirondack shares were sold. Right. Sweet. All right, that ends the lesson. So you can go to your CFU packet right now, and I want you to try all of these problems. So all of number 1 and then number 2. Okay? So go ahead and try that, and then go to the video to check to see how you did. Nice job today.